All right, so now we know how to run a tool. We know how to run raster tools. We know how to check for existence, set a workspace, and overwrite output data. So we were building up our repertoire of ArcGIS stuff. Let's move on, talk about a couple more things. We already know how to run any tool in the toolbox. We just did that. But there are a ton of things under ArcGIS that are non-tool methods. So we already looked at exists, actually. ArcGIS.exists, it'll tell you if something is there or not. It returns a Boolean. Describe, listing, and cursor. So we'll go into each of these somewhat briefly. We have some little pictures here. So we have, let's see, the one on the left, we just did that one. So setting a workspace and checking for existence. Notice in the one on the left, there's an ArcGIS.delete management. So you can delete data, just like you can right click in our catalog, delete. That's the delete tool. A lot of the things that we do in ArcGIS Pro have an equivalent toolbox tool for it so that you can run it from Python. The middle one here is describing. We'll get into that next, actually. And then on the right, I just want to point out there are a bunch of useful tools that we might not really use in ArcGIS Pro very often, but when you're writing code, they are very useful. So if you want to do a selection and you want to do you want to make that selection output be in memory, select layer by attribute and select layer by location are the two tools for that. And they are the equivalent. They are the equivalent of using the select attribute and select by location up here, but they're a toolbox tool and they work a little bit differently. Make feature layer is another way to make an in-memory layer to work with. It's related to selections. And then copy features. So if you ever have selections in Python and you're doing selections and your output's in memory and you just want to like make a copy of the data or export it, or like save a selection out, copy features is the tool for that. And so that's one that we don't really use the toolbox tool very much in ArcGIS Pro. But let's say I had a selection on my map. You know how you can go to data export features? The ArcGIS.copy features is the equivalent tool of that. All right, let's talk about how we can get data properties. So one thing that is really important and very useful, I guess, is the ability to pull properties out of data and then use that information to know what to do next in a script. So you might want to know if a data set is a vector or a raster. Is it a feature class? Is it a tip? Is it a grid? Is it a shapefile? Is the workspace that has been set a regular folder or a geodatabase? All of these types of characteristics of the data can control or can impact what we might want to do to the data or what we might want to call it. For example, with a shapefile, you may or may not know that a shapefile field name can only be 10 characters long. So if you were creating a new field in a table to do some calculation, you might name it differently depending on if it was a shapefile or a geodatabase feature class. Likewise, I don't think I have it in this screenshot here, but we'll look at it in a second. You might want to know if something is projected or not. What is the projection? Is it a geographic coordinate system? If so, then maybe you don't want to run the near tool on it. Maybe you want to project it before you run other types of tools. So you can pull all those properties out of the data. And you can do that with something called describe. So here on the screenshot, we are setting a workspace and we're pointing to a layer. Apparently, I really like LYR as a variable name. And then the way describe works is, notice right here, we have DFC equals ArcGIS.describe, and then our variable called LYR. So describe is a method that we call on ArcGIS that will basically create a new object. The describe method will create a new object. In this case, we're calling it DFC. And think of DSC as a giant bundle of all of the data properties of the thing you just described. So if you were in here and you went to your properties and you went to source, think of the describe object as an object that holds all of these things: data type, the name, the feature type, the extent, the spatial reference, everything in here, all in one object. So it's a very complex object. So because it's a complex object, we can't just print DSC, there's too much. DSC has a whole bunch of properties, and so we can pull out each property one at a time. So down here, that's what we're doing. We're pulling out individual properties, shape type, data set type, catalog path. And so there's a whole ton, dozens of different categories of properties, depending on what you describe. And you can pull them out and get what you need. And sometimes you might print them like I'm doing here. Sometimes you might use it in an if statement. If DSC.spatialReference.type equals geographic, then we want to project it to UTM. So you can use it in an if statement as well. We have some help documents here, and I'm going to start with the top one. Describe is, it's a lot. There's a lot in there. And for most of what you do with coding, you're not going to do this off the top of your head. You're going to use the help. Make that a little bit bigger. You're going to use the help. You're going to use the syntax and the code samples in the help to get you where you need to be. So this is the main describe page. And so these are all the different like categories of properties that are out there. Most of the categories are specific to a type of object you might be describing. I'm going to jump to feature class. I'm going to click on the feature class properties link, and it will tell me all the different properties that might be available on any vector layer I describe. So I could get the feature type. I could get whether or not it has M values or Z values. I could get the name of the shape field. Most importantly, probably, I can get the shape type. Is it a point, line, or polygon? And you can use that in an if statement. Oops. So these help documents here, I would highly recommend looking at those and kind of becoming familiar with what the different properties are and how to access them. I'll also show you that on the bottom of any help page, you get a code sample. So this is like fabulous. This is why when I teach my programming class, we learn ArcGIS first, because as much as people complain about Esri and ArcGIS products, their help documentation is really good. It really spoils you, and it gives you so many examples of what you need. So here's an example of describing CAD data and then printing out some properties there. So you can look in any help document and it will give you some really good stuff. If I go up to describe object properties, scroll down to code sample, here's another code sample that's actually using an if statement to check to see if a property is available for the thing that you described, and only print it out if it's available. And by available, I mean, like if you describe a raster data set and then try to get the shape type of a raster, that's not going to work because a raster doesn't have a shape type. So if it has the attribute shape type or data type, then print it out. So use the help and use the code samples because they're really good. All right, just some examples just to give you a general idea of what describe options are out there. So here we have name, spatial reference name. Notice that there's another piece in there, dot spatial reference dot name. There's another level to go into. Data set type, data type. These are some pretty common ones that I think you'll likely be using the most if you do this stuff. Any questions? Okay. Another thing you can do, which we'll touch on later when we get into tables, is you can also use describe to get to the fields. So if you want to know what fields are in a layer, you can use describe for that, which is this example right here. Or there's another way called list fields, which is what we'll actually do later. And that's like this. Sometimes you just want to know if a field is there, and then use that in a query or something like that. All right, let's go back to another demo. So what we're going to do now is go back into either ArcGIS Pro or PyCharm. And now we're going to be looking at Python Demo 2. Notice that in all the list of notebooks, we have solution code as well. So if you want to see, if you weren't able to follow along or you missed something, the solution code is there. And the solution code is listed in here as an IPYNB notebook file. And the solution code is also saved. If you look in File Explorer, you'll see the solution code is also an HTML file that you can open in Chrome. So all the stuff that we are typing and filling in, you have for your reference. All right, so let's open up Python Demo 2 notebook, or go to PyCharm and open up Python Demo 2, the script, which will look like this. This one has a few blanks. See, there's some blank lines in there, so I'm making you work now. I'm going to fill in some stuff. For this one here, we're going to be talking about describe. So we have the basic properties here. Oh, I don't have the link. Sorry. I don't have the link in here, but it's in the slide. But for this script, we'll need to run each cell one at a time and fill in the code. So first we'll import ArcPy. Great. The next thing we'll need to do is set up our own workspace because everyone has their stuff saved in a different location. So again, grab that location of your Fort Collins geodatabase. This one. So just go to File Explorer or the catalog pane, copy the path to the Fort Collins geodatabase, and paste it right into here. And make sure that R is there so it reads it correctly. All right, now we're going to make a variable for any of the data sets we want. You can look in catalog. We were using city parks before, but pick any one you want. It doesn't matter. I'll do hydrology now, sure. And what we're going to do is describe some properties of the layer that we just picked. So what was the name of the method that pulls out all these properties? Describe. Perfect. Spell it correctly. All right. So it goes arcpy.describe, and then in the parentheses, the name of the object that we are describing. And so we have a variable for it, right? We called it LYR. We can just pass an LYR for that. And now we have what we will have soon will be DFC. DFC is just a variable that we called DFC, DEFC, whatever you want to call it, as long as it's something meaningful and descriptive, so you know that that is the object holding your described properties. And then down here, I want everyone to write the code to print out a couple of properties. And I have a few listed up here. So just like we saw on the slide here, print out a couple of properties and see what comes out. See what works, see what doesn't work, see what it returns. So pick a couple that are interesting to you. Like print DFC dot shape type. And do a couple different ones. And then when you're ready, hit Shift Enter. Oh yeah, of course. What did I do wrong? Who knows Python and has a good eye for how print statements should be formatted?
I think you need a parentheses.
I definitely needed parentheses. So I learned on Python 2, and you didn't need parentheses then. And it's been years since I've been on Python version 3, and I still always forget my parentheses. See, did it again. PSC dot. So I printed out shape type and data type. And then notice that down here, I had a sentence already written out for you. Because when you print stuff out, like seeing the word polygon by itself might be a little bit out of context. So it's nice to have a little bit more information. And for what I have here is called an F string. And it's just a way to build a sentence, like to build a string. F stands for format. And then what it allows you to do is type in your own text along with variables. And so the variables get passed in curly brackets. So LYR variable, data type is, the red means it's my own text that I'm writing. And then the black in the curly brackets is the variable again. So just to show you an example of how you can fill that out. All right, are things working for you guys? Oh, I think what happened. You need, yeah, you need slash Fort Collins dash. Yeah, backslash. And backslash. And then Fort Collins dash. So that's the folder name. Oh, and that's not the geospatial. Yeah, you can just put that up here.
I also
That's fine. I don't think we have them.
Oh,
But we, if you talk to the control from there.
sure, okay. I thought
All right. Did everyone get their stuff to run? Did you play around
I
with
have
it?
a question.
Yeah.
Why did it print out as city parks data type is? Because I thought we were describing hydrology.
Oh, yeah. Oh, I know why. Because I think I changed it to hydrology, but I did not run the cell. And so LYR was still pointing to city parks because I never ran it to update it. So I just ran mine. Let me just make sure. I just ran mine and let me run this again. And now it's correct.
Oh, so is that why the lines are kind of consecutive? You know, okay, it's still calling on the first Python code.
Each cell has to be run, but whatever you ran previously will still be in memory. And so it was remembering the other pointer for LYR. Thanks for pointing that out. And then Brooke has a question. There's an error about not being able to be grid. Hold on, I can't. It's so tiny.
Sorry, I can read the error too.
Oh, no, I made it bigger. So
Okay.
a grid is a specific type of raster format that gets saved in a folder. And I think, what is your workspace set to? It gets cut off. Is it set all the way to the .gdb?
It's not set to the .gdb because when I had the .gdb, it said that there was a different error. So, but when I deleted the dot, then it said it was okay.
Okay, so I think it's giving you an error about a grid because it's trying to save a raster to a regular folder without a file extension. And that will create this other type of raster format called a grid. So I think the solution would be to set your workspace all the way to the .gdb and then figure
Okay.
out the other
The
area.
.gdb. Okay, that makes sense. Okay, I'll try that.
Okay. Yeah, grid is just an older raster format. I don't recommend them.
Yeah, that worked. Yeah.
Okay, good. Oops. All right, so one thing that you can do with like data type and data set type, like for data type here, it's feature class. I'm going to change mine and rerun it to data set type. Notice the data set type is also feature class. I can never remember which is which, but if you needed to figure out if something was a shapefile or a geodatabase feature class, data type or data set type would tell you that. So use these to your benefit when you're trying to figure out like what things should be called, what operations can be run. Like a shapefile can't have domains made for it. It won't have a shape area field. A geodatabase will have a shape area field. So you can use this to better write your code and automate things. You can anticipate what fields might be there or what things might be called. All right, the bottom part of this demo is to look at projection information, which is really important because when you're running analysis, when you're running tools, projection is everything, you know, and you want to know what units you're in. You want to make sure that you're not doing buffers on GCS data near the poles, you know, you'll get egg-shaped buffers. So you can use the describe as the starting point to get into spatial reference. So notice that down here, you can do DSC dot spatial reference dot any one of the dozens of different spatial reference properties. So if you take a look in here, we have a link, and this link is pure gold right here because there are so many spatial reference properties. There are several different pages in the help system related to ArcGIS and spatial reference. This is the one that has all the properties listed, but there are other ones that might have other useful stuff as well. But if we scroll down a little bit, a lot. Spatial reference, it's a class. I think it's officially a class. So it's like a group of objects kind of packaged together that you can access by one object, but you can create a spatial reference. Like if you're creating a new empty feature class that you're going to do something with, or you want to specify the output spatial reference for what a tool should be going into, you can literally create your own spatial reference item. That's not what we're going to deal with. That's a little bit different. So that's what this part is that is on screen. I'm going to scroll down past that to the properties. So if you have an existing data set and you run describe and you do describe dot spatial reference dot, any one of these properties or what could follow that dot. So DSC dot spatial reference dot GCS, DSC dot spatial reference dot factory code. So any one of these properties might give you some more information about the spatial reference of the data. You can get the name, you can get the PCS name, you can get the abbreviated name. So different ways to get the name of the spatial reference. You can get the factory code. And if you're not familiar with the factory code is a 4 or 6 digit unique identifier for every single coordinate system and datum and zone. It's completely unique. And they are the EPSG codes. Which one do I want? I'm not sure. I'll do this first one. Every single combination of coordinate system and datum has a code. If I try to look up UTM zone 13, NAT 83. Oh boy. Somewhere in this list, I would find the one I would want, and it's like 26913 or something. So if you need to specify what projection something is going to be in, the factory code is like a unique number that you can just make it be, and you know it will be what you want. And they're tied to the datum, so you don't have to worry about, oh, did I pick the right datum? So that's what that is, factory code, very useful.
Each zone, particular space that has ground truth reference and all that.
Yeah, so within UTM, the world is chopped up into 60 slices. And each zone, each of the 60 different zones have their own projection applied to that little sliver of the world.
Yeah, so we're gonna define set of launch between.
Between two lines of longitude. And the projection is applied in that area.
So the zone runs from the north pole to south pole.
Correct. And so as long as you're in that zone, like if you're just within Colorado, then you're all in zone 13, mostly. And that might be the projection you want to use for your map of the Front Range or something. But every projection, every combination of projection and datum has its own code. And it's sometimes a lot easier and a lot more bulletproof than using just the name. But here are some common ones. So name, type. Type would be like geographic or projected. The factory code. And then the linear unit name is your map unit. So what is the map unit? It's meters. So if you run, say, the near tool, what units are my distance values in the table after a near tool? The linear unit name will tell you that. So programmatically, you can get to all of this. So here back in our notebook, here's an example of just printing out the spatial reference .name. So I'm going to just hit Shift Enter on this and run it. And you can see it prints out NAD 27, Colorado North. How old is this data? But it's NAD 27, I don't know. But take a moment now and play around with a couple of the other ones. Oh yeah, and Abdullah asked a question, what's the difference between UTM 13S and N? Thank you, Danica, that's correct. It's the North and South Hemisphere. Yeah, so play around with a couple more and just see what comes out. And you can cheat by copying and pasting and changing it. Oh, okay, apparently that's 0. I don't know why that factory code is 0. That's weird. Okay, some of them are not very exciting. The properties are not case sensitive. A lot of the ArcGIS methods are case sensitive, but these ones are not. So like before, when we were doing the buffer, if I had a lowercase b, it would say ArcGIS has no attribute buffer because it's a lowercase b. One thing about the notebooks is that you don't get all of the syntax checking that a real IDE does. So another mark against the notebook. But like if I was in PyCharm and started to type things, it would give me code completion if I had it imported, which I don't. But it would give you code completion and it would actually help you along writing your code. The other thing about PyCharm is that if you type anything wrong, like if I forgot my closed quotation mark, in PyCharm I get a red squiggle and it'll tell me it needs a quotation mark. So the IDE is really nice for writing your code in that sense. Okay. The other thing I want to point out here, which is mentioned on the bottom below the cell, is that you can use this in an if statement. Hold on. You can do something like if the dot name doesn't equal what you're hoping it will be, now I'm going to have to type that, won't I? 1927. Jeez, Colorado. I couldn't paste it north. Oh my goodness. Okay, so if it doesn't equal that, then maybe I want to run the project tool. So you can use these properties to tell it when to do certain things. Any questions? I'm not going to finish that if statement. I'm just going to comment it out. All right. And when you're in your notebook, I'm not sure if it auto saves, but there's a save button up here. So if you like what you're typing in here and you want to keep it, you can hit save. All right, let's go back to the slide. So we talked about running tools, talked about describing data, talked about projection information. Let's go back now. We'll talk a little bit about listing data, which I don't actually have in that picture. So we'll just kind of dive right into, thanks, Hadi, thanks for coming. We'll dive right into listing. And for this, we'll just look at the help. So let's go back to here. And I'm going to save my Python demo 2 and close it. And now we're going to move on to Python demo 3. So Python demo 3 will teach us how we can point to a workspace or point to a data set and then list things from it. And by things, I mean point to a workspace and list all the rasters in it, or list all the feature classes in it. Point to a layer and list all the fields in it, things like that. So first, let's take a look in the notebook right here. We have a link to the listing data. If you are in PyCharm, let me close demo 2, open demo 3. If you're in PyCharm, in the top part of the comments, we have that same link. Oh, wait, sorry, top, very top. There it is. Same link, listing data, which I should click. We'll go to. If you're ever in the ArcGIS Pro help, by the way, and you need to find something, there's a search bar. So it's a good practice to do like ArcPy listing data. That will get you more of the ArcPy stuff as opposed to anything generic. If you know the name of the method or tool that you want to run, the actual tool names don't have spaces. And so if you type in like ArcPy list feature classes, all one word, it will help you find it more quickly. Okay, but I gave you the direct link, so we're here at just the home page for creating lists of data. And here are all the different types of objects we can create lists for. The way it works is you have to make a list of each type of object, kind of one at a time. So you can make a list of fields, and that will let you point to a layer. You can filter it. Notice how they all have some type of wildcard or type filter. Here we have list feature classes. So I can list all the feature classes in a location. Notice that my syntax here doesn't have a space for the location. Like, what is the folder that I'm listing the feature classes for? I'm going to click on this link right now so we can go to the whole page for list feature classes. But notice under this, there's one note. There's one very important note right here. For most of the list methods, you have to set your workspace first in order for it to work. And what it will do is make a list of the feature classes in whatever your workspace is set to. Previously, like in the other demo here, we set our workspace and then we set our layer. We could have just put the full path in here. It was a choice to set the workspace. It was convenient. But when we do our listing, it's required. So you have to set your workspace first, and then you can run your syntax, and it will list everything in the workspace. So if we look at ArcGIS Pro, I'm going to take a look on the catalog pane on the right, and I'm going to open up my data folder and open up my 4 columns geodatabase. When I'm looking at it in here, I can visually see what feature classes, what vector layers are in the geodatabase. But to do that programmatically, that's what the list feature classes will do. So let's write a little code to just do a quick thing with that. So we'll import ArcPy. Again, we'll set our workspace. There you go. No, okay. was trying to get it from there, but it didn't work. So grab your workspace again and put it into the right spot here in arcpy.env.workspace. And shift enter to run it so it's in memory. For this case, we don't actually need LYR. I'm gonna comment that out. We don't actually need that one. And then down here in this cell, it says create a list of the feature classes in the workspace. So now we're going to call the list feature classes method, and then we'll see how the syntax works. So in the blank, let's type in the name of the method that we need to pass in, and that will be list feature classes, all one word, spelled correctly, classes. And we could actually leave the parentheses blank. We need to have them there, but they can be blank. What this will do is run the list feature classes on the workspace, and it will return an object to us. And what it returns is a list, literally a Python list of the string names. So all the names of the feature classes as strings, of the string names of each feature class in that geodatabase. And then, as we should know about looping in Python and for loops, we can then loop through that list with a for loop. So down here in the blank, we can loop through FC list with a for loop. And we just print out each one at a time. So fill in list feature classes and FC list here. And I'm going to hit Shift Enter to run. And there they are. So FC is really just a string representing the name of each feature class. But now what I can do if I scroll down, it's all filled in down here. Now what I can do is use FC in other operations. So while you have FC, the value of FC is going to change each time the loop goes. But now FC is an object that I could run tools on. So I could run a buffer, I could run a project, I could run describe inside my loop, and it will do it for each one. So that's what this is doing right here. So I recommend doing shape type, and then maybe adding another line in here and print out another property. ArcPy.describe FC. Notice how we're doing the describe and the print and the property all in one line. That's another way to do it. I'm going to do path. And hold on, don't run it because this part's not filled in yet. But that's what you can do. So imagine the possibilities that you can do batch processing with anything in here. Another neat thing you can do, which is actually a toolbox tool, is called get count. So for each feature class, maybe you want to know how many features it has. And so you can use get count on FC as well. We learned previously that to run any tool, we have to put the alias in here. Do we have the alias here yet? Nope. What toolbox is get count coming from? Let's look it up. Any tool in here can be run through Python, and there are so many in here that you might not know about. So get count is one. You'll probably never run get count on your own, not from like regular ArcGIS, but from Python, I use it all the time. And it's coming from the data management toolbox. So this in my notebook, this line right here in my notebook should be arcpy.management.getCount. Look it over, make sure everything is looking good, and then hit Shift Enter to run it. And that's what I got. So it goes through each feature class in the geodatabase, and there's FC being printed out. There's my shape type. Here's my path. And then here's my get count, 194. Let's go back up and make some changes. I'm going to go to data. I'm going to go to 4 columns. I'm going to change it. Maybe I only want to work with layers that start with the word city. So every now and then you might have a project where you're only concerned with some data, layers that contain a certain set of characters or a certain date, and you want to filter by that date. In this case, let's get everything that starts with the word city. So in my list feature classes, I can add a wildcard and filter by type. The wildcard is first, the feature type is second. Feature type means I could list only the polygon layers or only the line layers. And like all the other help documents, you can scroll to the bottom and see a code sample to get some ideas for how it should be set up. Okay, so I'm going to go back into here and I'm going to add a wildcard, and it's going to be city star quotation mark. That will only grab the ones that start with the word city. I'm going to run it again, and hopefully it works. And look, I only got the ones that start with city. So if you have a huge geodatabase with tons of data in it and you only want a few, you can filter out what you need. Okay, any questions? Are things working for people? Related to this, is there anything else that you are curious about or want to see?
Beth, can you scroll back up to your code for where you filtered?
Yep.
Thanks.
So the asterisk there is like the wildcard character. And so if you wanted, I don't have a good example, but if you wanted something that contains city anywhere in it, you could do asterisk before and after. If you wanted something that ended in the word city, you could have the asterisk before and have the word city at the end. So you can play around with that to get what you need. Okay, I mentioned that there are lots of different list methods out there for all the different types of objects. So I'm going to go back to the help. I'm going to hit back a page to get back to the list of list methods. And notice there's also one for rasters. If you do list feature classes, it will only give you vector data. If you do list rasters, it will only give you rasters. If you do list data sets, I have students who have done this, actually one that I just graded today, who did list data sets thinking that would get them everything. It doesn't. If you want to get everything, you have to pick out, you have to like run multiple list methods. It's kind of weird. There's no catch-all. Individual vector layers are not considered a data set, so they won't actually get picked up when you do it that way. Let's see. Let's take a look now at the next thing in that notebook or in the script. So down here in the script, way down here in the script, the bottom is a little bit about list fields. So I'm going to go back into my notebook, scroll down. You can also get to the fields. And so for that, we saw just previously that you can do it using describe. So you can use describe dsc.fields, whatever your describe object is, like dsc.fields, and you can get fields that way. Or in this case, we are using list fields. List fields will work on a layer. So in this case, you actually have to tell it what table or what layer or what feature class you want to get the fields of, and that's what's going in here. You can also filter. So you could filter, we can look at this in a moment, but you can also filter by what the name of the field is or the type of field. I only want to get the text field. I only want to get the integer field. But when you run list fields, let me get a little bit bigger. It will return a list object, just like the list feature classes or list rasters would. It will return a list object that is a list of field objects. Each field object is itself a complex object. So if you want to loop through each field object in the field list, you can't just print field like we did with the FC names. It doesn't give you back a string. So print FLD, notice my comment there, that will work, but it won't be pretty, and we'll see it in a second. What you need to do is print out a property of the field. And so how do you know what those are? Again, that's the help. So in the notebook and in the script, you can see there's a link here to the list fields help page. And the list fields help page will show you how to run the tool. But then what it does is return a field object. And so this help page will tell you more about the field object and the properties that you can call from it. So if you have a field, you could do field dot type. You could do field dot scale. You could do field dot name. You could do field dot length. So you could do field dot any of these properties to pull out individual properties. And again, as always, the bottom of this page has a great help sample telling you how it can work. I should mention that some of these help samples, they're printing and they have this dot format. This is another way to build strings. It's an older way. The F string is a newer way that got introduced in Python 3. So this is just another way to do formatting. And it is the equivalent of, where do I have it? It's the equivalent of when I'm using the F string here. So if you see that dot format thing in the help, it's just another way to do the same thing. Okay, so let's go back into here and let's just run this script as it is, or run this cell as it is. And we'll see what it gives us. So it's pretty ugly. As you can see, we make the list of field objects, we loop through it, but then when we print just the field object, it tells us it's a funky field object. But then when we pull out individual properties, it prints out what we expect. So you typically will not be printing out fields, so let's comment that out. And then for the wildcard, up here for the list field, let's modify this line right here. And after LYR, let's type in PARK star. Oh yeah, that will only work if your LYR is city parks. What's my LYR right now? Oh, I do know. I'm going to go back to the top and I'm going to set LYR equal to city parks, which I didn't do before. I didn't think I needed it, but I do need it. Okay. So LYR, shift enter, make sure you run it. LYR is now the parks layer. And if my parks layer is set here, I can look for columns that only start with the word park. Shift enter to run. And now notice what I get. Park name is a string, park type is a string, park no is a small integer, which should really be short integer. But using this logic, you can also figure out if a field is in a table or not. And then determine if you need to add a field or not. You can also use this to figure out like what a field name is, what field name is in the table, and maybe what you should use for your query. Like, is it park name or is it just name? Park name equals Spring Canyon, you know, so you can use this to figure out how you should build your queries. Any questions on that? Okay, related to listing data, getting into fields, is there anything that you anticipate needing to do on the job or for your work that you want to know how to do? Okay.
Beth, I have just a really quick housekeeping question. I'm like trying to just copy and paste code within those little snippets, but I'm not able to. Is there a reason why? Like just,
Um,
right, like if I wanted to reuse those, like in,
It's not letting you copy and paste.
no, like, or should I be able to?
I had some issues copying and pasting as well, but I thought, huh, I don't know why.
Okay.
I know I had trouble copying and pasting the output, but I thought that you could copy and paste this. Are other folks having that? Have you tried copying and pasting? Have you tried copying and pasting any of the spells?
Yeah, I didn't, yeah.
Did it work? I don't know. I'll have to look into that, and I'm not sure.
Okay,
But
thanks.
mine doesn't seem to be working either. Control C. Oh, there's also this. There's a copy. I wonder if you tried using the buttons up top, if that would help.
Let me try.
That would copy a cell, but then you can modify it. Maybe. All right, any other questions? All right. Let's go back to the slides.